specifically hunt for planets that might be carving out gaps in that disk. It was perfectly set up.
Like looking down into a planetary construction site. Okay, so the how then involved JWST's MIRI instrument, mid-infrared.
That's the one, the mid-infrared instrument. MRI made the detection. And what this does is push down the lower mass limit for planets we can directly image. We're now potentially looking at finding worlds maybe down to, say, 25 or 30 Earth masses this way, which is a huge leap.
That really opens things up. But beyond just finding it, what does seeing it mean for understanding how planets form?
Well, this is where it gets really exciting for planet formation theories. This direct observation, it basically confirms predictions, but seeing is believing, right? It supports the core idea that planets form by material clumping together in these disks, gathering mass. And as they grow, they clear out these cavities or rings in the disk material.
Kind of like those little shepherd moons we see in Saturn's rings, keeping the gaps clear.
Exactly like that, yeah. Using their gravity to sweep paths and shape the structure. So seeing TWA7b apparently doing this, especially so far from its star, gives us direct, concrete evidence. It really forces us to think about how quickly and under what conditions these giant worlds can actually assemble, particularly at such huge distances.
Yeah, it's one thing to have models and simulations, but to see the planet in the cap it's likely clearing, that
Yeah.
feels different, revolutionary almost. So where do we go from here? What's next for studying PWA7b?
Well, the great thing is, TWA7b is basically perfectly positioned for follow-up studies.
Mm-hmm.
We can do detailed modeling, dynamic modeling of how the disk and planet are interacting. And crucially, we can perform direct spectroscopic investigations, look at its atmosphere, maybe even get clues about its interior composition.
Spectroscopy. So breaking down its light to see what it's made of.
Exactly. This gives us an unprecedented chance for comparative studies. Compare this young giant to, say, our own much older Saturn. So you see, it's not just about finding another planet. It's about watching planetary birth happen. It really underscores the power of JWST to directly explore these fundamental cosmic processes, things we only theorized about in detail before.
It really does, and it makes you think, doesn't it? How much more are we going to learn about how worlds form across the galaxy? Now that we have the tools, like Webb, to actually witness these processes unfolding light years away in such incredible detail, the universe seems like it always has more surprises up its sleeve. And we're just starting to capture those first amazing baby pictures.
Specifically hunt for planets that might be carving out gaps in that